I hope you all are good and getting benefits from the video lessons. Guys, today the topic what we are going to discuss is about the partial fraction. And before we start solving partial fraction questions, you should know the condition required for the partial fraction is one basic condition that the fraction must be proper, must be proper fraction. And you know what is proper fraction? In which the degree in numerator should be less than or smaller than the degree in denominator, right? And here in the for the partial fraction, we will divide all the concepts of partial fraction into four cases, and one other case is here for which the fraction is proper, fraction is proper, and linear terms in denominator. And let's see a question to help out this. Here comes the question. Yeah, I'm going to write it. Yes. Suppose we have a question. You are given a function f of x that is x square plus 7x minus 6 all divided by x minus 1 times x minus 2 times x plus 1. First of all, see the condition that is partial fraction is eligible here or not. You can see the degree in the numerator is 2 and the degree in denominator will be after multiplying these three linear terms, we will get x3, right? So it means numerator we have degree 2 and denominator we have degree 3. So numerator is smaller than denominator. So it means we can satisfy the condition that fraction is proper fraction, and thus case 1 is very much clear here that you can see we have a three linear terms in denominator. How many? Three linear terms in denominator. Here, let me make it correct, please. A question x minus 2 and x plus 1, right? We have three linear terms in denominator. So, in such cases, whenever you encounter linear terms in denominator, we will resolve the given question's fraction. A given fraction is this x minus 1 times x minus 2 times x plus 1. Like we will always use a single alphabet in like capital A divided by first linear term plus capital B divided by second linear term plus capital C over third linear term. It means after knowing the value of A, B, C, we will be able to resolve the given question fraction into partial fraction in three parts, right? So suppose this is equation number 1. And how to find the values of A, B, C? Before we find, you need to multiply the term whatever is in the denominator of the given fraction. Like this, we will need to multiply each term on both sides of equation 1 with x minus 1, x minus 2 and x plus 1. So let's see, we need to multiply x minus 1, x plus 2 times x plus 1 with x square plus 7x minus 6 divided by this one. I'm going to rewrite it equal to, and when a will multiply with this, the same with this x minus 1, x plus 2, plus 1 times a over x minus 1 plus again the same term x minus 1, x plus 2, x plus 1 times b divided by x minus 2 plus then again x minus 1, x plus 2 x plus 1 times c divided by x plus 1, right? And here we'll see the cancellation will take place. This whole will be cancelled with this. So left hand side of the equality, we left x square plus 7x minus 6 equal to, here with a x minus 1 cancelled, we get a times x plus 2 times x plus 1 plus, here x minus 2 will cancel, x plus 2, right? X minus 2 will be cancelled, it's minus, right? It's minus. So make it minus. So b with b, once this will cancel, we get x minus 1 times x plus 1 times b. And when with c, when x plus 1 cancel, this one, with c, we will get x minus 1 times x minus 2, right? So this goes to be equation number 2. Or further, if you want to, you can expand it. But for the linear cases, is enough. This make this equation number 2. Now for the values of a, b, and c, what to do? Whatever is in the denominator here of a, the first linear term, you need to put that equal to 0 to find x is equal to 1. And you need to put this value, x equal to 1, in equation number 2. And from, let me repeat, from where we get this one? We get this value from a. Here, I'm going to put an arrow. We took this from here and equate this to 0. And once we put it into equation number 2, we'll see 1 square plus 7 times 1 minus 6 equal to a times 1 minus 2 times 1 plus 1 plus, here 1 minus 1, 1 plus 1 times b plus c, 1 minus 1 times 1 minus 2. Here you can see 1 minus 1 is 0, so entire term becomes 0. B will be eliminated. And 1 minus 1 is 0, so C will also be eliminated. Only the A term left. A key point or the click point, that when you, for the linear cases, case 1 type question, when you substitute the linear term equal to 0, if it is in denominator of A, then you will get the result of A. If it is in the denominator of B, you equate to 0, you will get the value of B. And if the term which you equate to 0 from C, then you will get the C. Let's see. The next proceeding is come 1 plus 7 minus 6 equal to A times minus 1 times 2, and B and C left out. So we get 8 minus 2 is equal to minus 2A. So A comes to be minus 1 after dividing either side. So this is the value of A. Similarly, you can put value of the value which is in the denominator of B, that is what, x minus 2 to 0. So we will get x minus 2 equal to 0, implies x is equal to 2 in equation number 2. And left hand side, it will be 2 square plus 7 times 2 minus 6 equal to, here you can see, for A, when you put in equation number 2, 2 minus 2 is 0, so this will be 0. A eliminate. For C, again, C times 2 minus 2 is 0, so it will be eliminated. Only the result with B will be alive, that is 2 minus 1, 2 plus 1 times B. So squeeze you are working, and 4 plus 14, 18, minus become 12 equal to 3B. So B comes to be 4. And finally, C is left, and what is the term in the denominator of C? That is x plus 1, equate to this to 0. Here, uh, put x plus 1 equal to 0 implies that x is equal to minus 1 in equation 2. So you will see the left hand will be minus 1 square plus 7 times minus 1 minus 6 equal to, with a we have x plus 1, so here minus 1 plus 1 is 0, so a will eliminate. From b again minus 1 plus 1 0, so it will be eliminated. Only the case c will left, so you can write c times, that is here minus 1 and minus 1 minus 2. So simplify it, we get minus 14, no 6 and minus 13 is 12. Again minus 7 and minus 6 is minus 13 plus 1 minus 12 equal to minus 2 and minus 3 become minus plus 6 c. So c will be minus 2. So we have calculated the value of ABC. Therefore, final result, now you need to put the ABC in equation number 1. Final result is that x square plus 7x minus 6 divided by x minus 1, x minus 2, x plus 1 equal to, what is a? A is minus 1, so minus 1 over x minus 1, and b is 4 plus 4 divided by x minus 2, and c was minus 2 as well, so plus minus, we get a minus 2 over x plus 1. This is the final result, that we have resolved the given fraction into partial fraction. I hope it is clear. So this is a case 1 when you encountered linear term in denominator and the fraction is proper. Let's proceed to next question and see the case 2 when there is a case study that fraction is not proper but the terms are linear. Let's see. Okay guys, now we are going to discuss the case 2 of the partial fraction when the fraction is not proper. Not proper mean your numerator should be bigger than the degree of numerator. In short words, degree of numerator should be bigger than the degree of denominator or equal to. When is bigger or equal to both degrees, numerator degree is greater than or equal to denominator degree, then that fraction is called improper fraction. But we need to change that in proper fraction. That means in this case is for improper fraction. That justify the condition. Okay, for this case, and denominator has linear terms. So take the question to how can we solve this, and here goes the question. Okay, suppose we have, this is again question taken from the past year paper, and the question states resolve into partial fraction. This is the given case. First do check is the fraction is proper. You can see the degree in numerator is 2, you can see here, and degree in denominator is x times x is also 2. So that means that is improper fraction. So whenever you encounter improper fraction, you need to change that into proper fraction before resolving the given fraction into partial fraction. And for this case, simple case, I'm going to discuss with you, and you can carry all the questions whenever you encounter such condition in one go. Okay, roughly I can say you just do write the given questions numerator and do multiply the denominator, we get 3x square plus 2x minus 3x minus 2. So we can do this 12x square plus 4x minus 1 and divided by 3x square minus x minus 2, right? Now with the traditional way of division method like this, okay, we can take this on side way. Here we will divide it. Yes, numerator 12x square plus 4x 1, and this is kind of long division, and we already have done this in the past videos. The concept has been discussed. So if you are you are not sure about this correct division, you go through that videos. Long division, yeah, polynomials. Okay, here the rule is that 12x square should be cancelled with 3x, so that is will be 4. So 12x square, if you multiply this with this 4 should be multiplied with the entire term of this divisor, and this is divided, yeah, minus 4x minus 8, and you change the sign, it cancels, becomes 8x plus 7. So this is the quotient, and this is the this is what reminder, and this was the divisor. So the rule to write this quotient plus, let me write it here, quotient plus remainder over divisor. So given fraction, that again I'm going to write this. This is the same as this, right? We just multiply the denominator to make it division. Now write the original question, 12x square plus 4x minus 1 whole divided by x minus 1 times 3x plus 2 equal to, the quotient is 4 plus remainder was 8x plus 7, and the divisor was same. 3x square minus x minus 2 is same like the factor of x minus 1, 3x plus 2, right? Divisor is same. Okay, now you can see in the fraction, here I'm going to write this, highlight this one. This fraction resemble the case 1 whenever the fraction is proper, because in numerator we have degree 1 and denominator we have degree 2. So condition of partial fraction justified here. So and we have linear terms. So suppose this is equation number 1, we need to find the solution of this fraction that can be resolved, like write 8x plus 7 whole divided by x minus 1 times 3x plus 2, and it will be resolved into a divided by x minus 1 plus b divided by, because both are linear in denominator, so you can write a single alphabet. So now suppose this is equation 2. So as per rule, whatever is the denominator of the original question, multiply each term with it. We will see, here we get 8x plus 7. When you multiply this highlighted with a, x minus 1 will cancel, and we get with a 3x plus 2, and with b 3x plus 2 will cancel, and we will get x minus 1, right? I hope it is clear that what I did, I just let me write on the side that I multiply each term of equation 2 with x minus 1 and 3x plus 2, and we get this one, right? This result we get. Now what to do, as I told you, in the denominator whenever you encounter linear term, put them one by one equal to 0, like put x minus 1 equal to 0, that implies x is equal to 1. We need to put this in equation 2, this one, okay, equation number 3, in 3. 8 times 3 plus 7 equal to, you will see A with 3 times 1 3 plus 2, and B will be 0. You can see 1 minus 1 is 0. So if you don't want to write this, leave it. So 24 plus 7. What do we get? 31. Yeah, 6, 3. Yes, 8 is 24 plus 7. Okay, whatever is 5A. Then check the calculations. Yes, here we did a little mistake. We replaced x with 1. Na? So here 8 times 1. 8 plus 7 is 15. So that's fine. Okay, so A will be 3 by dividing with 5 on either side. A is 3. Similarly, once you will, okay, break it, you put the denominator of B is 3x plus 2 equal to 0, implies that you will get 3x equal to minus 2. So x is minus 2 by 3. We need to put in equation number 3 here. This is equation number 3, right? So you will see 3x is minus 2, right? So it's minus 2 plus 2, A will be eliminated, and only B will left. So 8 times minus 2 by 3 plus 7 in left hand side equal to A with 0, no need to rewrite, plus B will be minus 2 by 3 minus 1. Simplified become minus 16 by 3 plus 7 is equal to B times LCM is 3 minus 2 minus 3. Take the LCM, 3 becomes LCM, minus 16 plus 21 equal to minus 5 by 3 times B. So it will be 5 by 3 is equal to minus 5 by 3B. That implies B will be minus 1. I hope it's clear. It's a basic calculation. Now after, as we have calculated the value of A and B, so put it into, so you can see from 2 we get 8x plus 7 over x minus 1 times 3x plus 2 equal to, what is A? 3 divided by x minus 1, and B is minus 1, so plus times minus 1 over 3x plus 2. Now you need to substitute this result in 1. So you can say that from 1, the original question was 12x square plus 4x minus 1 whole divided by x minus 1 times 3x plus 2 equal to 4 plus and this above result. So this is my final answer, plus minus minus 1 over 3x plus 2. I hope it is clear. And this is a type 2, when you encounter a question in which the fraction is not proper. So the basic condition of partial fraction is the fraction must be proper. So here you need to go to convert the improper fraction into proper, like the long division method, and resolve the rest of the question into partial fraction. I hope it is clear. Let's proceed to next type. Okay guys. Okay guys, now we are going to discuss the third case of partial fraction, and here the case is when fraction is proper as per condition it must be before resolving into partial fraction. The given fraction must be proper fraction, and if it is improper, then we did case 2, and you can do the same steps what you have done in case 2. And here the denominator has linear terms. Its denominator is a multiple of linear terms with repeated roots. It means Repeated roots mean the linear term with power greater than 1. Let's do one question on the past year paper to help out this case. So here goes the question. Yeah, here's the question. Question states, given that your function f of x 9x squared plus 4 and 2x plus 1 times x minus 2 whole square. Here you can see guys, the first thing is clear, fraction is proper because the numerator degree is 2, but in denominator you will get 3 because x minus 2 whole square is x square and x multiplied to become x3. So degree is here, degree is 2 by 3. So this is a case study for the proper fraction that satisfy the condition to resolve. And this is x minus 2 whole square mean roots are repeated. So in such cases what to do? So simple, we are here to resolve x squared plus 4 divided by 2x plus 1 x minus 2 whole square. The condition stays with the linear terms, right? Linear terms. So for the linear term, we always use single alphabet, meaning a upon 2x plus 1 plus, and here linear with repeated roots. So keep writing the single alphabet with the increasing power, gradually increase the one power in the repeated roots. Any x minus 2 is going to repeat with 2 times. So you write x minus 2 power 1 and then b after b we have c divided by x minus 2 power 2. If it is x minus 2 power 3, then we will write d over x minus 2 power 3. Any you guys need to improve the power of the repeated root one by one gradually to come up for the maximum in the question. So here this is we can say this is equation number 1 and we are behind to find a, b and c. The same process, whatever is in the denominator of the original fraction, do multiply each term with this. Any A with this, B with this, and C with this here. And we will see what left. When you multiply here, it's only 9x squared plus 4 is left. And here, 2x plus 1 will be cancelled with the A, x minus 2 whole square is left. And with the b, x minus 2 once cancelled, so you get 2x plus 1 times x minus 2 with 1 power left because here is 1. And once you multiply the same with c, x minus 2 whole square will gone and x minus 2 whole square will go and we'll get c with 2x plus 1, right? And for such repeated roots, I would like to, expand the results like this: x4 9x square plus 4 is equal to a times it's a minus b whole square. Identity can be applied: x square minus 4x plus 4. And if you forget the identity, do multiply x minus 2 two times to get this result. With b, when you multiply this 2x with this and then this and same one with this and this, we'll see we get 2x squared minus 4x plus x minus 2, and with c we have 2x plus 1. Again, do one more step and be careful in your multiplication. If it is wrong, then everything will be wrong. So, and this will become minus 3x, like terms. Now multiply a, we get ax squared minus 4ax plus 4a. I multiplied a with each term inside the bracket. Same with b, plus 2bx squared, and this was minus 3bx minus 2b plus 2cx plus c, right? Now suppose this is equation number 2. Now as per here guys, what to do now? You need to, for the linear, as per rule, you will put the denominator term of a equal to 0. That's give you 2x is equal to minus 1 or x is equal to minus 1 by 2. Put this in equation number 2. And I told you that as a linear, so only a will be alive and rest will be dead. Yani left hand side 9 times minus 1 by 2 square plus 4 equal to 8 times minus 1 by 2 square minus, here I'm going to substitute this one. Okay, sorry, here into, so minus 1 by 2 square minus 4 a into minus 1 by 2 plus 4a, and b all and c will be 0. And how directly can I check? As this equation 2 comes from this portion, I'm going to highlight this one. So it means if I directly substitute these value here, I will tell you laterally why I expand every expression to become 2. So here you can see is x is what? 2x is minus 1. So minus 1 plus 1 b is 0, minus 1 plus 1 c is 0, only a left. Either you can do this one or you can directly put it here in this portion, right? Either you can put this in this portion star, it doesn't affect, make this equation number star. You will see we get 9 by 4 plus 4 equal to with a. If you put it directly, it comes to be minus 1 by 2 minus 5 by 2. So it's the same result we get. 1 by 4 plus 4 by 2 means 2a plus 4a. Is 4 is that if you multiply each one, okay, take LCM. 9 plus 16 is equal to a by 4 plus 6a by 1. So 25 by 4 is equal to again 25 by 4a. So a will be 1. I got a1. Right? Now the same, the next, what is the linear term with b? If you put x minus 2 equal to 0, implies that x equal to 2. In equation 2, oh no, its star is better. Here star is better. It's the same thing. If you either you can put it in 2. To save your calculation, I'm substituting in star. Why? When x is 2, you can see with a 2 minus 2, 2 minus 2 is 0, so a will eliminate, and b will also be eliminated because 2 minus 2, second term of b, 0. And left side we will get 9 into 2 square plus 4 is equal to 0a plus 0b plus, you can see only c will left, that is 2 to the 4 plus 1 5. So 5c equal to 4 and 36 plus 40, so c is equal to 8. Now only b left. You can see if I put c denominator equal to 0, then because the roots are repeated again you will get c. So we can't get b by keeping this process anymore. So that's why I made this equation number 2. Here what to do now, only one variable left, yani b left. Compare the coefficient. What is the highest degree in equation 2? X square. Okay, we write x square in equation 2. So here you can see left hand side we have 9 coefficient of x square, and right hand we have a plus 2b, and no more x square term. And in this, and this. So A already we have calculated, that is 1. So 9 is equal to 1 plus 2b. So 8 is equal to 2b. So b comes to be 4. So this is how we can calculate with the repeated root the values of the unknowns a, b, c, and the case is linear. Now substitute this in the question equation number 1. Final result is final result is 9x square plus 4 whole divided by 2x plus 1 times x minus 2 whole square. That gives me a is 1 over 2x plus 1, and plus b is 4 over x minus 2 with power 1, plus c is 8 over x minus 2 whole square. This is 5 marks question, and we have done this. I hope it is clear. Let's go for the final